Okay, hi everyone. We're going to learn how to do a chi-square test of independence. And this is when we're looking to see if there is an association or relationship between two nominal variables. So I'm going to be looking at, all right, how many cars are in each category of drive and how many cars are in each category of airbags, and is there an association between cars with different types of airbags? Is there an association with them and cars with different types of drive? And so to do this, first what I'd like to do, I don't have to worry too much about my assumptions. I do need to consider that these are randomly chosen, but the chi-square test is already a non-parametric test, so I really don't need to look at normal distributions or assumptions of homogeneity of variances. But it is a good idea still to just examine the data descriptively, just to see like how many are in each group. And just to look at that. So I'm going to just throw my airbags and my drive in here and just look at just what's going on here. So I've got 16 cars with both types of airbags, 43 cars with driver airbags, and then 34 cars with no airbags. All right. And then I can look here about their frequencies on type of drive. All right. So front wheel drive, there's a lot of cars. 16 cars with just rear wheel drive, and then 10 cars with both. All right, great. Another thing is to also look at it by group. So I'll do distribution, and I'm going to just divide this up so I can see how many cars with types of airbags are by drive. All right, so this is going to show me that it's going to show me, okay, so for cars who have both rear wheel and front wheel drive, about their airbags, driver airbags versus none, this is going to give me counts for that. All right, so this is showing me specific counts for each category. And that's also nice to look at. It just gives me an idea of how many cars are in each category. All right, so now I'm ready to conduct my non-parametric chi-square test of independence, which is different than a chi-square test of for goodness of fit. So there'll be a different video about that. So go to fit y by x, and I want to see if there is an association between drive and airbags. I got to think which one do I want to be the predictor variable and the criterion variable. Sometimes it really doesn't matter, but it is something to consider. Which one do I think is going to influence the other? I've got to say that very loosely, but maybe it's the type of drive that influences the airbags, all right, or that's what kind of drives the relationship. So you will see here, I've got this beautiful mosaic plot, all right, and so this gives me a visual for this is type of drive, so I can see that front wheel drive has a variety of types of airbags, right? So we've got a little bit of both type of airbags, a handful of, and then of driver side airbags, and then some of none. Now for cars who have both rear wheel and front wheel drive, it looks like none of those cars have both types of airbags. All right, is that right? What does both mean for airbags? I gotta think about that. All right, I want to keep going. Now, what I need to look at to see if there is indeed an association, my null hypothesis is there is no statistically significant association or relationship between drive and airbags. So look down here at this contingency table, And I'm going to do something to that in just a moment. But first, I need to look just to see if there is an association. So I'm going to look right down here at my chi-square test. I'm going to report this Pearson value. I'm going to write chi-square equals, all right, and so the chi-square degrees of freedom is 4, and the chi-square equals 9.83, and it is statistically significant with the alpha set at 0.05, so this would be the p-value that I report. But where are these associations? Like, what's associated with what? So it's kind of like I need to do a post hoc and look at where the association is. And so what I'll do, I'll go to contingency table and I'll click on expected, and then also click on cell chi-square. Now, what you have to do is you have to look right here and understand that this goes with this row. All right, that's the count. That's the number for each cell to show that front wheel drive has, oh, both meaning driver's seat and passenger seat, I bet. Okay, sorry, it's taken me a minute. Front wheel drive is 28 cars with driver side airbags. Now, what I really need to look at, what this is showing the math behind the chi-square, which is all based on observed percentages and expected percentages and expected values. So that's what it's showing here. But what I need to look at really is this cell chi-square, this row right here. Now, these are z-scores, and so I'm looking for z-scores that are plus or minus 1.96 or higher. All right, so anything above a 1.96 is 2 standard deviations. Above, it gets into the critical values where I would reject a null hypothesis, or possibly negative 1.96 or lower. All right, so I'm thinking about the tails. So I'm really looking for 1.96. If it's probably going to be positive. If it's bigger than that, then that's where the specific association is. So I'm looking here, don't see anything special. I don't see anything special, but I do see something special here. So indeed, there is a relationship between cars with rear wheel drive and no airbags. That sounds kind of dangerous to me. I don't know what this stuff means. Rear wheel drive. Don't know that much about cars. But I know there's an association between that kind of drive and no airbags because I know how to conduct a chi-square test. All right, so that is what we are looking at. Did I miss another value? See, this is pretty close, but it's not quite statistically significant. It would be statistically significant if my alpha was a 0.10. And so if you want to get out your JMP guide, or if you just want to take notes right now, if the alpha is a 0.05, you're looking for 1.96. If the alpha is a 0.01, you're looking for 2.58 as the magical critical value number. If the p-value is 0.10, then you can count anything with a 1.65 as the critical value. And so again, we're looking for it to be above those numbers. So that is how you conduct a chi-square test. And again, this is what you report down here. You're reporting the Pearson chi-square, but you're going to say chi-square, Greek symbol, equals, and then that's the number. This is the degrees of freedom. That's it. You guys have a great day.